Hello, and welcome to the Key Stage 4 chemistry topic, alkenes. Before we get started, can you please make sure you have a pen, paper, pencil, ruler, and either a highlighter or another coloured pen or pencil so you can mark your progress and self-assess. Can you also make sure that you're in a nice, quiet room without any distractions from technology and so you can completely focus on this learning session. First things first, can you write down a learning objective to understand what alkenes are and how they are formed? So just pause the learning session for 10 seconds. Okay, so we're going to start off with the retrieval practice. There are 3 questions on the screen here. Can you have a go at them and give yourselves 4 minutes for this? Have a go, and then we'll go through it in green pen and self-assess it. So 4 minutes, have a go now. Okay, the time is up there, guys. Can you pick up a green pen or another coloured pen or pencil, and we'll go through this and self-assess it now. So, question 1. Why is crude oil known as a finite resource? Well, finite, that means there is only a limited amount available. So underneath the Earth's crust, where the crude oil is, there's only a finite amount of it. There's only so much of it before it is completely gone. Question 2. What is the general formula of an alkane? So an alkane, that is CnH2n plus 2. So CnH2n plus 2. And then what happens during fractional distillation? So a brief description is the separation of a mixture, for example crude oil hydrocarbons, into its fractions according to its different boiling points. So crude oil is heated up into a gas and then it's separated out at the different boiling points where each version of the hydrocarbon in the crude oil, because it's a mixture of hydrocarbons, condenses back down into a liquid at different boiling points. So give yourself a mark out of 3 for that, guys. Excellent if you got 3. 2, well done. 1, let's add in corrections there and improve on that. So these are learning outcomes for today. So we're going to describe the properties of alkenes and then compare alkenes and alkanes. So just as a starter, guys, I want you to have a look at the image on the screen here, look at these 2 models, and then have a think and jot down what are the differences between them, what are the similarities, so what is the same between them or similar, and then what is each one, what are they called? What are these examples here, models called? So give yourself 2 minutes for that, have a think, jot down your ideas, and then we'll go through it. Okay, so we're going to go through these differences now, guys. Just going to go through them verbally, so make sure we're listening carefully to this as I'm going through them. So the differences between them. Well, the one on the left here has only a single bond between the 2 black molymods, or the 2 carbon atoms. So a single bond here, whereas this one has 2. It's a double bond between the carbon atoms. Another difference, there is only 1, 2, 3, 4 white molymods or hydrogens, whereas this one on the left has 6. So a couple of differences just there. Similarities, they both contain carbon, so the black molymods there, and they both contain the white, which is hydrogen as well. And then what are these called? Well, these are called molecular formulas or molymods. So just jot down that key information there, guys, and then we'll move on. Okay, so first task, guys, just a bit of a recap from a few previous learning sessions and lessons you may have done. So I want you to have a go, have a think, and then answer these down on a piece of paper or a Word document. Answer these 3 questions, guys, and give yourself 5 minutes for this. 5 minutes to recapping what the process of cracking is and why it's useful. So 5 minutes, go. Okay, your 5 minutes is up there, guys. Can you once again pick up a green pen or another coloured pen and pencil, and we're going to self-assess this now. So, question 1 or bullet point 1, what happens during cracking? Well, during cracking, a simple way of saying it is the long hydrocarbon chain, long chain hydrocarbon, is broken down into simpler substances, small substances, using heat in the process of thermal decomposition, and this produces an alkane, a smaller alkane, and a type of hydrocarbon called an alkene, which we're focusing on today. So, why is cracking useful? Well, cracking is useful because it helps to match the supply of fractions or each layer of the hydrocarbon crude oil that's been separated out with the demand for them. So there's a high demand for different fuels, for cars, for vans, for airplanes, for lots of different uses, plastics as well. And it helps to match the supply for that by using lots and lots of crude oil to break it down to each parts, and then so it can meet the demand. So it needs the supply to meet the demand of that. So since cracking converts larger hydrocarbons into the smaller ones, which are used for the fuels, the supply of fuels is improved. So the greater the supply to meet the demand of such fuels, and it helps match the supply with demand. That's the key part there. It helps to match the supply with demand for those fuels, those different fuels that we use on an everyday basis. And the final bullet point, what are the products of cracking? Well, the small hydrocarbons are in high demand for fuels, so they're very high demand, so the small hydrocarbons. Alkenes are used to produce polymers as well, and to make plastics, and starting materials for the production of many other chemicals in pharmacies and petrochemical uses as well. So if you just want to add those in, guys, and then we'll move on to the next part. Okay, so brief overview, guys, here of alkenes. They are a double E, so that means they're double bonded, so two E's in the name. They are unsaturated. That means there is a double bond in between the two carbons, and that's called the functional group. So between the two carbons, just there. The first part of the name isn't the same as the alkanes, but there is no methane, as all alkenes have a carbon double bond, and with CH4 that's not possible, and they are very reactive. Another key property of alkenes there. So your new task, guys, your next task, I want you to draw in this table as it is, and then complete the table by writing in and drawing in the displayed formula and the molecular model for ethene and propene. To give you a clue, molecular model is the images we saw on the previous slide. Displayed formula, I want to have a go at that, and then we'll go through it. So I'm going to give you 7 minutes for that, guys. Have a go, and then we'll go through it and assess it. 7 minutes, go. Okay, guys, hope you got a couple drawings there and complete the table there. If you do need a bit more time, remember just pause the video. That's absolutely fine. So, displayed formula, guys, we'll start off with that. It's a bit trickier. This is otherwise known as skeletal formula as well. And those are the images there on there. So they have a double bond between them, between the carbons as a functional group, and then a single bond to the hydrogen as well, because they are hydrocarbons, hydrogen and carbon together in a long chain polymer. So, propene, now the key part is it's not two groups of double bond. For it to be an alkene, it must have at least or just one double bond there. So that's this displayed formula there, guys. Molecular models, though, just drawings, something like that. So you show the two carbon atoms, 4 hydrogen atoms, shown with a double bond, and then single bonds to each of the hydrogens. And then the same for propene as well there. So just add that in, guys. Pause the video if you need to. So we've had a go at that, guys. What I'm to do is draw the following alkenes: butene, pentene, and hexene. But can you do this in its displayed formula? So displayed formula, not the molecular formula. So displayed formula, please. Pause the video for 5 minutes once again and have a go. Okay, guys, I hope you have had a go at that, drawing those displayed formulas of butene, pentene, and hexene. If you're struggling, butene contains 4 carbons, pentene 5, and hexene 6. Now the hint, hopefully look to the hint, now they do look similar to alkanes, but the key part for drawing these, guys, and having a go is that carbons only can have a maximum of 4 bonds or 4 lines attached to each. So, going to look at butene first. So butene, it's going to come up now, and make sure we add in any corrections. So butene, remember, has 4 carbons, all surrounded by hydrogen, and it almost have 4 lines or 4 bonds for each carbon. Now, it also contains a functional group here for the double carbon bonds, and as it's got 4 carbons, it is butene. So can you add those in? Pause the video if needs be, or give yourself a mark. Okay, next one, pentene. So that means it's got 5. So it follows a similar structure, but this time an extra carbon on the end. So remember, with the double bonded functional group, that means it is an alkene, needs to be double bonded, and then surrounded by hydrogens as well. And then for hexene, you're just noticing a trend, you're adding a carbon on that time. Just adding a carbon on at the end here. So same, still got a double bonded functional group, but it's got a carbon at the end. Excellent. If you've got 3 out of 3, guys, fantastic work there. 2, well done. 1, let's just add in a couple corrections there and keep on going. Okay, guys, now your next task, I want you to compare the differences and the similarities between alkenes and alkanes. So your success criteria is just on the screen there. You're going to state the general formula for both, discuss saturation, so which one's saturated and unsaturated, and the bonding for both. Draw an example of each hydrocarbon has 3 carbons within it, so a displayed formula, and then name the first 4 hydrocarbons in each group of alkenes and alkanes. So drawing a table, compare them both using the success criteria to help you. I will give you 10 minutes for that guys, so pause the video for 10 minutes, have a go, and then we'll return and go through it. Okay, 10 minutes up there, guys. Can you pick up a green pen or another coloured pen and pencil, and you'll self-assess what we've done there and add in any corrections that may be needed. So, alkanes on the left-hand side, alkenes on the right-hand side, a few differences there. Key points here, obviously, alkanes are single, they are saturated. Alkenes must have a double bond, they are a functional group, which means they're reactive. And the differences is in the endings of each one. So methane, ethane, propane, butane. But remember, there's no methane, it's ethane, propene, butene, and pentene. So pause the video, guys, add in any corrections. Fantastic if you got all of that. Well done there. Okay, guys, your next progress check, just on balancing equations. I want you to write a possible word and symbol equation for cracking decane, the alkane, that produces an ethene molecule as well. So pause the video just for 2 minutes, writing the word and symbol equation for that, producing ethene, and have a go. So 2 minutes, go. Okay, hopefully you got these 2, guys. Give yourselves 2 marks if you've got these. So first one, decane plus octane, which is 8, makes ethene, and then C10H22. You react that together, breaking it down by cracking C8H18 plus C2H4. So add those in, guys. Excellent if you've got both of them. Really well done. Same again, guys. Can you pause the video for 3 minutes this time? Write in the full symbol equations, please, and add in any corrections as well when we go through it. Okay, guys, so pick up your green pens or another coloured pen and pencil. We're going to self-assess this now. The answers will come up now, so can you add those in? Give yourself a mark out of 3. So C4H8, C14H30, and C12H26. Give yourself a mark, guys. Out of there. 3, excellent. 2, well done. 1, let's improve in that for next time. The last task, guys, GCSE question. I want you to pause the video. Once again, final task, plenty of task, and have a go at these. We'll go through them in 2 minutes time. Okay, guys, going to quickly go through this. So A, which product of reaction shown is an alkane? So an alkane, remember C6H14. How do we know? We use the formula CnH2n plus 2, and then the answer for B was, of course, B as well. Excellent if you got both of those, guys. Brilliant work there. That concludes the learning session on Key Stage 4 Chemistry Alkenes. Have a wonderful day, guys. Take care.